Good evening, class. We're going to get started right now, and tonight we're going to be talking about lesson 1.7 and 1.8. In particular, we're going to be talking about inductive reasoning, which is 1.7, and also looking for a pattern, which is a problem-solving lesson, and that's lesson 1.8. And these two lessons go perfectly together. So let's go ahead and get started, and let's talk a little bit about what inductive reasoning is. Well, I think when we talk about this is going to sound kind of familiar. What inductive reasoning is it is making conclusions based on patterns that you observe. Now, I want you to stop thinking about math for just a moment and think about the other classes that you've been taking, okay? Does this sound at all familiar? Inductive reasoning. So we're going to make conclusions based on patterns we observe. Well, if you're thinking like I am, that probably sounds a lot like the scientific method that you study in your science classes. Okay? In fact, when we're doing inductive reasoning in mathematics, we're going to look at patterns, and when we come up with something that we think is a rule that governs that pattern, we're going to call it a conjecture. Now, a conjecture is our best guess at what the pattern is, and then we're going to kind of test out our conjecture and see if it's correct. Well, again, this ought to remind you of science class and scientific method. So our conjectures are going to be kind of analogous to a hypothesis that you're going to be testing in a science lab. So inductive reasoning is really nothing new. This is just a mathematical way at looking at what you already do in your science classes. All right, so let's go ahead and practice this for a second. Here's an example of inductive reasoning. Take a look at this pattern, okay, with the little marbles, okay, and I think from just those first three patterns you can probably figure that each time we're adding on a marble. So the fourth term here is going to probably look something like this, except it's probably going to be pink. Okay, and then the next one will be same thing, but this time it's going to be 5. And we can continue this pattern on. So if I wanted to describe this pattern, I'd say, all right, each time I add an additional marble or rock or whatever this is. Okay, let's take a look at another problem. This one's also a visual one, and this time we're getting a little pyramid of rocks. Okay, so take a look at the first 3 patterns, or the first 3 examples, and then try to think about what the 4th picture would look like. All right, I'm going to switch to the correct color. And if you're thinking that it's probably going to have 4 marbles along the base, and then 3 marbles on top of those, and 2 marbles on top of those, and 1 marble on top of that, I believe that you are correct. All right, let's take another, one more visual example. Take a look at the following pattern. Okay, so we start with a triangle, and then the second one has a circle wrapped around the triangle. The third one starts with the same triangle, a circle wrapped around that, and then a square. Now this one's a lot trickier. I want you to really think carefully about what the next 2 pictures would look like in this sequence. All right, so look for things that are in common, and look at what we're doing each time. All right. All right, I want you to go ahead and pause for just a moment until you actually have in your mind, or maybe even better, you sketch on paper, what those next 2 pictures are going to look like. And as soon as you feel like you've got a pretty good conjecture, or a pretty good idea what those next 2 are going to be, go ahead and unpause me, and we'll see if we agree. All right, go ahead and pause your video right now. Okay. Well, I hope that you did what I asked and you paused it, and I think that the next one is going to start with the same exact triangle that we had in the first 3, same exact circle that we've had for the last 2. We have a square around the outside of that, and it seems that after we put a polygon into the picture, it seems that we add a circle. So the next picture, I think, is going to have a circle around what we've got so far, and this is going to be a little hard to draw, but I think if you listen carefully, the 5th one, we'll start with the triangle, with a circle around that, and a square around that, and a circle around that, and then finally, a little harder to draw, a pentagon around that. So each time, the polygon has one more side, and then every other picture, 2nd, 4th, and then the next one, the 6th one, we put a circle around the outside. Now I know that's a little harder. Usually when you see a picture like this in your textbook or on a worksheet, it's going to be a little easier to see than with me drawing with a stylus on the iPad. Now, let's move on, because not all patterns that you're going to be looking at have anything to do with geometry or pictures. Okay, so let's take a look at a pattern that has just numbers. Okay, so let's start with 5, 10, 15. Okay, and think about what number is going to come next in that pattern. Okay, and I think you can probably recognize we're counting by fives. So the next two numbers are going to be 25, and we can keep going, 30. We're just going to count by fives. Okay, so that my conjecture is that the continuing of this pattern is just going to be continued count by fives. Okay, here's another example: 1, 4, 7, 10. I gave you one more this time because this pattern's a little trickier. Okay, and again, take a look at this. Go ahead and pause the video. Think about this one for a second. When you think you've got the answer, go ahead and unpause me. Okay, so go ahead and pause now. All right, if you're unpausing me, you must think you've got the pattern. Okay, so what numbers would come next? 1, 4, 7, 10. And if you look at the numbers from 1 to 4, 4 to 7, and 7 to 10, I think you'll notice there's a common difference. We're always adding 3. Well, once you recognize that, now the next two terms would be easy. The next one will be 13, followed by 16, and we can continue that pattern as long as we want. Okay, so that's an example of using inductive reasoning, looking at a pattern and trying to figure out what the rule is, and then using that to come up with the next couple terms. All right, let's do one more with numbers. This one's a lot harder. Okay, 1, 2, 4, 7, 11. Now I really want you to look at this one hard and see if you can't come up with the pattern that's happening here. You might want to do something similar to what we did on B. That's a little hint. So go ahead and pause me now until you feel like you've got it. All right, were you able to figure that one out? Well, again, my little clue, if you look at the differences from 1 to 2, and then from 2 to 4, and then from 4 to 7, and then from 7 to 11, and notice I did give you 5 terms. You notice in the first one we're adding 1, in the second one we're adding 2, then we add 3, then we add 4. So if we continue that pattern, we're going to add 5, add 6. So that means that the next number would be 16. And then if I add 6 to that, I get 22, and I can continue from there. Okay? So in each of these cases, whether we're looking at patterns of shapes or figures, or we're looking at numbers, we're using inductive reasoning. All right. Now, let's talk a little bit more about a conjecture. So when we think we've looked at the pattern and we've figured out what's going on, we're going to make a conjecture. And again, that's just like a hypothesis in science class. All right. Now, we're going to test out that conjecture, and sometimes we might not have enough information, or maybe more than one conjecture, more than one rule could give us the same pattern. Okay. Now, usually the simpler pattern is usually going to be the right answer, but sometimes we need to gather a little bit of evidence. However, if we can find just one example that makes our conjecture false, okay, then we call that a counterexample. And a counterexample, it really only takes one of those to say that, no, our conjecture is not right. Now, sometimes we can go back and we can fix our conjecture, okay, and maybe modify it a little bit, and then the counterexample won't work anymore, okay? But one counterexample is all it takes to mess up a perfectly good conjecture, okay? Just like in science class, if you think that you know how something works and you do an experiment and it proves that, no, it doesn't really work that way, well, then you kind of got to go back to the drawing board. You go ahead and establish that. That's good science. You found something out. You found out that your hypothesis didn't work. Well, it's the same thing in math. All right. So again, counterexample, if you do find one that proves your conjecture false, it only takes one, then you got to go back to the drawing board. All right. Now, let's transition. Let's use the same idea of inductive reasoning, and let's apply it to a real-life word problem and work on some problem solving. Okay. Now, if you were with me last year in course one lesson every chapter we stopped and we did problem solving. Well, the same is going to be true this year. Okay. So when we look at 1.8, we're going to look at problem solving, and just like we were just talking about in inductive reasoning, the problem solving lesson that we're going to focus on, or the strategy that we're going to focus on tonight, is looking for a pattern. All right. So here's a problem. Suppose that we've got this scenario where a rumor spreads or news spreads. Okay, and when somebody finds out the news, they kind of think about it, and 15 minutes later they tell exactly 2 people, and then they don't repeat it to anybody else. All right? So each student who hears a story, I'm just reading the problem in front of us, hears a story, repeats it exactly 15 minutes later to 2 students who have not yet heard it, and then they tell no one else. So suppose that one student heard some news at 8 a.m. How many students would know the news at 9 o'clock? All right? So again, anytime we have a word problem, it's really important to kind of read through the problem a couple times. Okay? So look through that problem again, look for the important information, and let's work forward and come up with a plan. Okay, now, rather than just give away the solution right now, I'd like you to just maybe take a moment, look at this question, and see if you can figure out the answer. All right, there's a lot of different methods you might try. Scratch them down, and when you think you've got an answer of how many students are going to go at 9, go ahead and come back to this video. So pause me now, take a couple minutes and take a look at this problem and see what you come up with, and then go ahead and resume this recording, and we'll go through what I came up with as my solution. Okay, and you may agree or disagree with my method, and we'll talk about that more in class tomorrow if there are some disagreements. Okay, so go ahead and pause, and come back in just a moment. All right, well, welcome back. All right, well, I really hope that you figured this out. And rather than give it away right now, let me show you how I approach this problem. And what I'm going to do is I'm going to take the time from 8 o'clock up until 9 o'clock, and I'm going to spread that out for a second on a number line. And the reason I'm going to do this is I want to be really careful about when other people are finding out. So here's my one student that finds out at 8 o'clock. So I'm going to divide this number line up into 4 pieces. And so this is going to represent 8:15, 8:30, and 8:45. All right, so this is the time span that the problem is starting with. And I think this first step is pretty obvious. So one person knows at 8 o'clock, and at 8:15 they tell 2 more people. What might be a little less obvious is the total number of people that know right now are 3, the original person plus the 2 new people. All right, now the 2 new people, we don't worry about this first one. They're not going to tell anybody else. The 2 new people go and tell 2 more people at 8:30. So now 4 new people find out. And let's keep a running total, okay? And I know that looks kind of like a fraction. I probably should take that back. Let's keep a running total down here on the bottom of how many people know at this point. So 3 people know plus 4 new, that's 7. Okay, 8:45, the same thing happens. The 4 people that found out tell 2 people each. That's going to be 8 new people that find out. And our total now goes to 15 people. And we're almost done, but we're going to allow for 9 o'clock to come. And at 9 o'clock, the 8 people that just found out at 8:45 are going to tell 2 people each. And that's going to be 16 new people for a grand total of 31 students. Okay, so if you got 31 students, good job. That was a great application of inductive reasoning and some problem solving. Now we're going to dig into some problems like this in class. So be thinking about how to find patterns and how to follow them for real life problems. All right. Well, as always, we tend to have 3 words somewhere in the video, and so today we're going to end with "that's a wrap." As you think about your daily quiz tomorrow, since it's been a couple of days, think about some of the key concepts. You might want to review back through this video about some of the analogies we made between inductive reasoning, math class, and science, and we'll pick up where we left off tomorrow in class. So have a great night. Thanks for listening, and I'll see you all tomorrow. Goodbye.